Earlier, I had said that there are multiple different kinds of loops. Primarily, there's the while loop, and we've seen that in two styles. This program is going to introduce for loops, which I prefer to use for some instances. So let's take a look at an example of a for loop. So just like a while loop usually starts with the word while, for loop starts with the word for. Now, the part that people get a little bit hung up on here is the declaration line for the for loop. I'll break it down into three components, and hopefully it will make sense. So just like in a while loop, often we have a part where we are initializing some kind of variable, and then we have some sort of end condition, and then we have some sort of increment or growth that we have. So these are the three components to declaring a for loop. So what we're going to do is, first step, we're going to type int I, and then we're going to set this as equal to 1. So this component is initializing the variable I at 1. And the cool thing is, with the word int here, it's actually declaring the variable within the scope of the loop. Okay, so now what we're going to do is we're going to keep this going. So this is the end condition, is the second part that we enter. So while I is less than or equal to 10. So again, that's like a while condition. So if I is less than or equal to 10, then loop this thing. And then the last part is we are going to grow the I variable. So every time we are going to grow it by 1. So we're going to type in I plus plus. This is like the most basic for loop you can possibly imagine. So every time we go through the loop, what I want to do is I'm going to see out I, and we'll put an end L here. So when we run this, we'll take a look at what I is. So I'm going to run this, and then here's what we get. We get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So essentially what happens is when it hits the for loop line, I get set to 1, and then it goes through the loop. It prints a 1, and then it goes back to the top and then checks to see, okay, it grows at first. So I will become 2, and then it checks to see, okay, should I run this loop again? Yep, 2 is fine. So it goes through, prints the 2, goes up, becomes 3, and it sort of repeats that pattern until it becomes 10. So we'll take a look at another example here. But the first thing that's important to note is I'm going to check. I want to find out when this is finished what the value of I is. So typically the loop will end when this becomes false. So what will have to have happened is I will have become 11, which will make the central end condition a false statement, and then it breaks out of the loop. So let's take a look at what I is equal to, and I'm going to pull up the output here so that you can see this right away. Okay, take a look at this. Now we have an error. So this was deliberately created here. Now, this is an important error, and I want to talk about this word here at the end, scope. So it's telling us there's an error. I was not declared in this scope, and it's telling us that the error is on line 15 here. So let's take a look at this. It's telling us that there is no variable I in existence here. And that's because what happens is at the end of the for loop, I is destroyed. So I only exists, this is what we call within the scope of the for loop. So in the scope of the remainder of the program, I currently does not exist. So what we could do is for the next loop, we'll declare the variable before we actually get started. So I'm going to make an int I here, and we'll set this to be 10. So what we're going to do is we're going to do this for in reverse. So actually I don't need to set this here. So we've got int I, and we're going to do a for. Now instead of putting the int, we're just going to say I, and typically you set what the variable has as a beginning value. So we're going to set it to 10 at this point, which is part of the initialization, which is why I did not need to give it the value 10 at the initial stage. This is going to be while I is larger than or equal to 1. And instead of the increment, which is the plus plus, we're going to put the decrement here. And then we are going to cout I and L. And just for this last one, after the loop is finished, let's find out what actually happens. I'm going to cout and L. And then I'm going to cout I, and then cout, whoop, and then another and L here. So that will go from 10 down to 1, and then we'll find out what I is after the loop separated by a line. So let's run this and find out what we get. Okay, so we get 1 to 10, 10 down to 1, and then we can see that after the loop, I is 0. So again, as I said, this for loop here, what happens is I is 1 on the last run of the loop. It goes back to the beginning. I shrinks by 1 and becomes 0. And then this becomes a false statement, and then the loop ends. So this is pretty common. Now we're just going to do one more thing. At the very bottom, we're going to introduce another variable, int total equals 0. So we'll put an accumulator here. Now, what you can also do is you can base your for loop based on some previously set value. So I'm going to have int olive jars. So what we're going to do is we're going to have a certain amount of olive jars, and then we'll ask the user how many are in each, and then we'll come up with our total. So we'll go olives here. All right, so let's get going with this. Now, here's something interesting. We're going to start this out with for int I equals 1. So normally a program will not let you do this. It won't let you declare a second variable named I, but what happens is it is going to use this variable I inside the for loop. It's going to destroy it, and as soon as the loop is finished, the program is going to revert to using this value of I. So this is why you want to be very careful, or, frankly, even just give them different names, and then you won't have this problem. But then what we're going to do is we're going to have this go while I is less than or equal to the amount of olive jars that we have, and then we're going to go I plus plus. So just so this program doesn't run forever, let's set the amount of olive jars to 3. Okay, so in here we're going to cout how many olives in jar, and then we'll put I, and a little separator here, CN olives, and then total is going to get the value of total plus olives. So it's going to add on that amount of olives every time, and then we're going to see out total number of olives. This is going to be the total. There we go. So, and then we'll run that program. We're going to get a bunch of counting, and then it's going to actually get to this part of the program. So, what we're going to do, let's see if I can get this high enough. How many olives in jar 1? I'm going to say 3, in jar 2, 3, and in jar 3, 3. And then the total number of olives is 9 for this. So that is interesting for two reasons. One, this part is important because we can use some variable to determine how many times we're going to go through the loop. In addition, it's important to note that the variable that we declare within the scope of the for loop can actually override one or be in supplement to the one that exists in the main program. So obviously there would be no way in the for loop to access what the version of I outside of the loop is, but there you have it.